Hello, welcome back to our video series covering the Hex Grid plugin in Unreal Engine 5. In this video we'll just be looking at the blueprint, and in the next video we'll be going through some of the demo content and some of the additional blueprints that are included. So picking up from where we left off, we've got this Hex Grid blueprint. We're going to go ahead and go into this blueprint now, and we're going to talk about how it works. So if we come over to our construction script, or just double click on your construction script function, this is really the bread and butter of the actual plugin. So there are 3 stages it goes through. And one thing to really mention now early on is there's a big separation between the grid generation and the meshing step. And the reason we do this is because generally speaking, the grid generation isn't likely to change too much. You don't need to customize that so much. And so separating it out into its own section just keeps things simpler for you. And so you don't have to worry about the actual grid generation side of things. Once you get that working well, you don't need to touch it again. So the general running order for our system in the construction script is we delete out the old grid first. This is a requirement of the construction script because of the way it reruns and it kind of maintains variables. So we need to make sure we clear this out every time we run it. If you're just generating your grid at runtime in Event Graph, you don't need to do this. But this is very important for the construction script. And all it does is clear up the variables and delete out any meshes that exist. Next up, we generate the grid, and if we just step into this for a second, it's very simple. Most of the grid generation happens in C++ because that's much more optimized for mathematical functions, and it's much less likely to throw certain errors in terms of big for loops because we potentially are looping through a lot of things, and Blueprint doesn't always like nested for loops. So having a quick look here, we work out our grid scale calculated, and this is where we set that X and Y on the grid spacing, and that generally won't change. And then we go through, we take your grid shape that you've requested, say hexagon or rectangle, and then we generate that grid array. Once we've got that, we store it in a variable called grid. And this variable, this grid variable, is going to be really, really useful. You're going to be accessing it potentially a lot. So good to be aware that this is where the whole grid is stored. And this is just a 2D index grid. It's not offset in a hexagonal shape or anything because it is just 0, 0, 0, 1, 0, 2, so on for the size of your grid. If we come back to our construction script now, we can look in our populate grid, and this is where a lot of the meshing happens and metadata, and this is what you're going to be customizing for your projects most likely. So if we go into populate grid, the first thing we do, and let's just make a little bit of space here, and let's close this down too. So if we're using instances, we go ahead and create an instance static mesh component. We only create one and we set the base mesh for it. And if you are not using instances, then you can just go ahead and delete this. It's not used, it won't be relevant to you. If you are creating instances, be aware this is where it gets made, just in case you want to select your instance static mesh and modify attributes on the details panel for it. And if we just go back to window and details, which I closed down, and select our instance static mesh, this is where you set up your kind of basics. So what mesh is going to use, what material, any sort of special attributes you want on your instance mesh. We don't expose them all out because you don't need to be changing it too often. Then once we've set up our instance, or skip that if we're not using them, we go through our grid and we loop through the grid. So this is really important. Once we loop through the grid, we're going to create a little data asset to go with each tile. And this is just a useful way to store metadata, and we'll talk about that in a bit. And then we store our current grid index. After that, for each grid tile, because remember we're still in our for loop, we're either going to spawn a static mesh, an instance, or a blueprint. Now, whichever one of these you're using, you're going to want to customize this heavily, and you don't need the others. You can pretty much just delete these out. Let's have a quick look at static meshes because this is the most relevant, kind of go-to basic. And the way it essentially works is we have this scale and offset node. And what this does is it takes the actual coordinate we're on, say 5, 5, and it takes the current grid scale. Let's say we set it to 0 on X because it's auto-calculated, and 90 on the Y, which is the default we have. And this will work out an actual position for your grid. So it takes the raw index, say 0 and 1, it's going to scale that up so that it matches your grid scale, and it's then going to offset each alternative row to give you a hexagonal shape rather than a grid shape. So because essentially a hexagonal grid is just a normal square grid, and we offset the index so that it becomes hexagonal. So each The odd row is 50% to the right of the even rows, that type of thing. So once we store that, we go ahead and set our meshes, and then basically we have this current data asset that we created previously, and this is just this little metadata file. So we can go through the metadata now, and we can store information that we want to know about for this tile. So if you were going to, you wanted to kind of come up with a seeding system or some sort of randomization, you want to say this tile is going to be a farm tile, this tile is going to be a river tile, you're going to want to store this in your current data asset, and that way you've got that to fall back on. Also worth knowing is we take our coordinate and we turn that into a name, and we add that as a tag on our static mesh component. This is kind of the primary way to access the coordinates when you're doing things like line traces. Then we just go ahead and update our data asset a few times. I won't go into this too much. And then we have this choose tile type for static meshes. And this is your like seeding system. So I'll quickly show you mine. And essentially all we're doing in our version is we're taking a random ball with weight, and we're saying, should it be a pond? Where's a 20% chance of being a pond? If it is, go ahead and set it to a pond mesh. And we update our tile cost. And we haven't covered this just yet, but we have pathfinding in the grid, and we'll talk about this in the next video where we go over the demo content. But this is setting like how much it costs for the unit to path over this tile. So if you have a river, maybe it's twice as expensive as land to walk over. If you have a desert, maybe the sandy desert is very hard to walk in, and that's 3 times the cost. So we would say the water tile cost is 4 times as expensive as a standard tile to pass over. So just something to be aware of here. If it's going to be a mountain, so if it's not, so you can see we say chance of ponds. If it is a pond, do this. If it's not a pond, maybe it's going to be a mountain. We have a 10% chance of it being a mountain tile, and if true, just set it to a mountain mesh. And in this case, we also have a tile blocked set, and this defines that a tile cannot be passed by the pathfinding system, either flood fills or A-star. And we just add it to this blocked set. So this mesh is not relevant to be pathed on at all. If your game doesn't include pathfinding, then just don't worry about this. Just delete these out. They're not relevant to you. But if you are using the pathfinding, then you want to make sure you set your paths correctly. Lastly, if it's not a river and it's not a mountain, then just go ahead and set it to a default tile and give it a standard cost map of 1. And that's it, really. So this is how we kind of auto-generate our little grid. And if we just minimize this blueprint for a second and have a look at our hex grid in the world, if we scroll down to, where is it now? Chance of mountain, here we go. On our seeding, we've got this chance of mountains, chance of ponds. If we make this 0.5, then we're going to have 50% of all tiles are going to be ponds. If we make this mountains 50% or 0.5, then we'll have 50% chance of mountains on every tile. So this is kind of just a very, very crude example of how you might seed your grid if you're trying to do more of a kind of a Civ style game, or a game where your grid has kind of random tiles to it. And this is something you probably want to rewrite dramatically based on your project. Just be aware that when you set your meshes, if you're using pathfinding, you want to set up the tile cost map and the tile blocked map. Every single tile should be in the tile cost map. So whatever you add should have a cost of, say, 1 if that's your default cost, and then you can modify other tiles. So maybe you have a motorway tile or a road tile, you could give this a cost of 0.5, so it's more optimal to walk on than a standard tile. And that's just one way you can modify the pathfinding. So we're going to back out of this now, and we come back to our add static mesh. The last thing we do in my example is we create a dynamic material instance for each mesh on the tile, on the grid, sorry. So if you want to be able to change the meshing, the material on each mesh, you can go ahead and have this. If you're not going to do that, delete it out. It would save you, a little bit of performance, probably negligible performance, but nevertheless, if you're not doing that, you can delete it. I'm going to go ahead and close some of these tabs down now, and we'll go back to our construction script. Populate grid. We've got this add instance and add blueprints. You can go into these and have a little look at how these work, but they're similar to static mesh, but static mesh is the most powerful because it's the one that we can have the most control of. Instances are generally hard to work with in terms of per mesh settings, so that's just a limitation to be aware of. And blueprints we're generally going to control in the blueprint, not in the master grid. So again, that's something you want to control. Lastly, in here, we just add debugging coordinates, and I can show you that too if I minimize this and have a look at debug options. So if we scroll down to debugging, we can change this to offset coordinates, and this is going to render the coordinate on your grid. This can be useful in the early days when you're first kind of learning where the coordinates go and how you might want to debug certain things. Be aware that rendering this much text is very performance heavy. This is not something you want to do in game, obviously. It's just there for you as the developer to get things right. So I'm going to go ahead and change this back to none, so there's no debugging, and go back to our hex grid. So that is essentially where you want to customize this kind of populate grid function, and within that, which instance system you're using, which meshing system you're using. So you can customize this to your leisure, however you want. Now, if I go over to the event graph, it's just a couple of things to note in here. We have a little example of how we might load or save a grid. This is only saving our current grid. So as you customize, as you build out your game, your project, you're going to need to improve this loading and saving to save your content into the grid. So this is also something you're going to need to look into. If you're familiar with loading and saving, just the standard blueprint method, it's the same system, so it should be easy to expand. And below that, we've just got some general overviews of the nodes that are available. All the functionality in the Hex Grid system is built into a C++ blueprint function library, and that means you can access it from any blueprint. So you don't need to be in the Hex Grid to access it. You don't need to cast to the Hex Grid to access it. Most of these nodes are going to take an origin or a grid as an input, so you'll just need access to that information. You can kind of go through these at your leisure, and we're going to cover a lot of them in the demo video in the next video. But one just I want to point out is how you will path, how you actually access the offset coordinates. Because there are so many games where you're going to want to be able to click on a grid or tell a unit to find a grid tile, and this is just useful to know about. So we have 3 examples here for get the coordinate under finger, get it under cursor, or do a line trace. These are your kind of a very common one to use when you're using a grid. And we've got kind of 4 methods to show, 2 of which are demoed here and 2 I'm going to create for you. If you're using instances, then you need to use the hit item here. So this is the only real way to grab the actual per instance ID. And from there, if you get your hit item, you can take our metadata information, which is all stored in this metadata map. You can get the values from that metadata map. And again, this is something you might want to, have a little play with yourself to see how it works. But we can loop through all of the metadata and we can get the instance ID. And if it matches our current hit item, then that's the tile. We can get our coordinate out of our metadata and do whatever we like with this coordinate, run all of our functionality. If all you have access to is a location, such as you have a little NPC who's standing on a tile and he has access to his location, you can use this find closest tile to a location. This is not a C++ function. This is just a normal blueprint function. It's generally quite expensive because it has to loop through the whole grid to find the tile that's closest. And it won't exit early because it needs to go through every tile to find the tile it is closest. So you can use this, but only use it on click or irregularly. Don't use it on tick. Lastly, and the simplest method, if you're using static meshes, if you recall, if we come back to our construction script, populate static meshes, we actually gave the mesh itself a component tag and we passed it the coordinate. So this is by far the cheapest method. If you come off a component, if we're using static meshes, or it'll be active if you're using blueprints, and just say get tags, and then from there we know we put it into tag 0, so we'll just get a reference to tag 0, and from there we'll just do a pass, and this will pass the name to offset, which is one of our special hex grid functions. Now we have the offset coordinate, and it's as simple as that. So this is really, really cheap. This costs no performance to use, really. It's just a simple string check. This is by far the best way. So now you've got your offset coordinate, you can run functionality, you can run A-star pathfinding, etc. Very, very straightforwards. If you're using blueprints, you could do a similar approach. You could get our hit actor and we could get tags from the actor itself, and then you could do it that way. But be aware that we haven't currently added tags to blueprints just yet. This is coming in a future update, so you'll need to add it yourself. But it's really, really easy. Go construction script, populate grid, add blueprints, and then in here, when we spawn our actor, all we have to do is we have to just get tags, and then we can just insert a tag at index 0. And then for our tag itself, we'll just do pass offset to name, and then there's our coordinates local right there. Plug that in, and now we have access to tags on our actor. And this is going to get included hopefully in the 5.4 edition of the grid, but right now you can just add this yourself and just plug it in up there. So that's it for the Hex Grids blueprint. So one last thing just to cover is the metadata file. So we've got this Hex Grid data asset here. If we open this up, this is the current metadata we store per tile. So we create one of these assets every time we create a tile. Now the default system is mostly just core information. Is it an instance? Is it a static? What's the static mesh? Does it have a material instance? Is it a blueprint? And therefore, have you got a blueprint reference? These are just kind of bare bones metadata options. But if you want, you can go ahead and open the full blueprint editor. Go ahead and add new variables to this for, is it a farm tile? Is it a castle tile? Is the tile currently taken? Is it spawning money? Whatever you want your tile metadata to be, this could be an option for you to store that information. So you can add it in as a variable. And then when we go back to our Hex Grid, we can access that very easily. We can just search for metadata. And we've got this Hex Grid metadata. Let's just go back to our event graph for a second and come back to a blank place. All we need from this is we can take our metadata and we can say find, and then all we need access to is our offset coordinate. Most of our functionality relies on you passing in a coordinate. So let's say we did that line trace and we have access now to our coordinate from our tag. From there, we've got our little data asset that we created, and we can do whatever we like to that. So we could get instance ID, get this ISM component, get his instance, and any variables you created will be accessible here. So now we know, hey, get our offset coordinate, great, is an instance, blah, blah, blah. Or, you know, if it's a castle tile, is it a castle tile? Search for is castle. If that was a variable we'd made, it would appear, and then you can work with that however you want. So that's an easy way to store information for the grid without having to do anything weird and complicated like spawning special blueprints to store data or writing it to a data array or something like that. This is just a nice simple built-in solution for storing it. You don't need to use this, and if you're using the blueprint method, so if we are mesh component type blueprints, then maybe you can just store your metadata in the blueprint and you don't need this metadata file itself. This file is mostly for people who are using static meshes or instances who need a way of storing information with a tile. So that's it. Hopefully that was a good kind of blueprint overview. It was all quite fast, I know, but just kind of a general get you started, and from there you can dig into them and play with them and have a little look at how it all works. And in the next video, we're going to show you the demo content, which should really help you find the functionality you need. So make sure you watch that one. Thanks for watching.